Hello, boys and girls. We are now doing Unit 5, Module 2, Session 3, which is called Line Symmetry. Before we start the lesson, I want to go ahead and go over the homework from last night from Home Connection book pages 96 and 97. So work will vary. Yours may be a little bit different than this, but the first one, number 1, it says to draw at least 2 examples of each of the following. If you can't remember what the words mean, look at the guide to geometry terms on page 95. So remember that page 95 was just a guide page to help you to complete 96 and 97. So for A, here are 2 possible examples of parallel lines. Remember that they are never going to meet. They are always equidistant from each other. For B, you have perpendicular lines. Whenever they intersect or meet, they form right angles. So there's 2 examples of those. For C, you have right angle, and here are 2 examples of right angles. For D, you have obtuse angles. And for E, you have acute angles. Again, yours might look a little bit different, but these are just examples of what they could look like. On page 97, draw at least one shape that matches each description below. For each shape, use arrows and words to show how your shape matches the description. So here's an example, a quadrilateral with 2 pairs of parallel sides. So you can see the first pair of parallel sides and the second pair of parallel sides. So for a quadrilateral with only 1 pair of parallel sides, that would be a trapezoid. It has 4 sides, so it's a quadrilateral, and the top and the bottom sides are parallel. For B, a pentagon with exactly 1 right angle and exactly 1 acute angle. So a pentagon has 5 sides. You can see it's 1 right angle and it's 1 acute angle. Here's the right one. Here's the acute angle, and then you have some obtuse angles there. And then for C, a hexagon with exactly 1 pair of perpendicular sides. So here are those perpendicular sides, which also again is that right angle. And then D, a hexagon with exactly 1 pair of parallel sides. So this side right here is parallel to this right here, okay? There you have some example answers. Yours might look a little bit different though. All right, so moving on to Unit 5, Module 2, Session 3, Line Symmetry. In this session, we will learn about the idea of relative symmetry. We will examine examples and non-examples to help us define the term, and then we will identify symmetrical shapes and their lines of symmetry. We will also work on drawing lines of symmetry. Remember that parallel lines are lines that will never cross. They are the same distance apart. Remember that perpendicular lines are lines that cross over each other, intersect, and they form right angles. Today we will talk about line symmetry, symmetrical, and line of symmetry. Think about these terms. Have you ever heard of them before? You may remember that if you have a shape like this, a square, a line of symmetry would be when I can take that shape and I can simply cut it in half. So you can see that it kind of, if I were to fold it, it's going to fold over each other, okay? This shape, however, since it's a square, it not only has 1 line of symmetry, it has a second line of symmetry right there. I could actually fold this square again. And if you look very carefully, it has another line of symmetry there. And another line of symmetry there, meaning that I could fold it over and it could meet on the other side. So when a shape is symmetrical, that simply means that it has a line of symmetry, okay? All right, so now thinking about line symmetry, look at the pictures in the boxes. What do the shapes in the left-hand box have in common? These figures all have at least 1 line of symmetry, okay? So I could take this triangle and I can cut it in half right there. I can take the trapezoid and I can cut it in half right there. I already showed you the square, but I can go like this. Whoopsies, whoa. Yikes, let me try that again. Square. The H can be cut in half this way, but it could also be cut in half that way if Mrs. Sanders could draw straight. The triangle could be cut in half this way, or this way. Now that's not every triangle, but this is an equilateral triangle, which means that you can cut it in half like that and it'll match up on each side. This rhombus can be cut in half here. It could also be cut in half there, all right? Okay, so there's some lines of symmetry. Now when you look at the shapes on the other side, they don't have lines of symmetry, meaning that there isn't a way that I can fold them where they would match up on both sides. So this S, for example, a lot of people confuse the S's because they think that they can cut it right here and that it will match up, and it is not going to match up. Or they might think, oh, I can cut the shape this way and it will match up. And again, it's not going to match up because of the way that an S is shaped, okay? So there are many letters that do have lines of symmetry, like the letter M, W, H, O, and there are also many letters that do not have lines of symmetry. So these are asymmetrical figures. Okay, so a line of symmetry. A line of symmetry, a real or imaginary line that divides a shape into two mirror images. So this rectangle, you can see that it has two lines of symmetry. This silly blob shape right here only has one, meaning I can only cut it in half two ways where it's going to mirror image each other. Same with this one. This one only has one, and then this one has 1, 2, 3, 4 lines of symmetry. You will notice that some shapes have more than one line of symmetry. Think about why that might be. Okay, I want you to open up your student book to page 184. Go ahead and take out a pencil. Okay, give you a little bit of time to do that. All right, thinking about line symmetry. So we've talked about the top pictures. So now we're on number 1. Study the diagram above and use it to help you answer the questions below. A, circle all the shapes below that have at least one line of symmetry. Use a colored pencil and a ruler to draw the line of symmetry on the shapes that you circled. If you have a colored pencil and a ruler, you can do that. If you don't, it's not the end of the world, right? Okay, so this one has symmetry. So I'm going to circle the ones that have symmetry first. This one does not, so I'm going to cross that one out. It does not have symmetry. This one also does not. This one right here has symmetry. This one right here has symmetry. This one does not. And these two do have symmetry. Now I'm going to use my green to put where the lines of symmetry are. This one has a line of symmetry here, and it also has a line of symmetry right there. This triangle has one line of symmetry right there. This triangle has one line of symmetry right there. This interesting almost triangle shape has one line of symmetry right there. And this oval has two lines of symmetry, one there and one there. Again, if you have colored pencils, go ahead and use them. If you don't, just use your pencil, kind of like I did, okay? All right, for B, draw two shapes of your own that have at least one line of symmetry. So I'm going to draw two shapes, but I want you to draw different two shapes. So use a different colored pencil to draw a line of symmetry on each if you have colored pencils. Here will be my examples. Now I know I'm not drawing exactly perfect here, but I have a trapezoid, and its line of symmetry would be right there if this were a perfect trapezoid. I know it's not perfect, and I'm sorry. All right, and then my other one, I'm going to go like this, and I'm going to draw an equilateral triangle, and I will show you the lines of symmetry on that. 1, 2, 3. So this one has 3. This one only has 1. All right. So you're going to also draw two shapes. I drew a trapezoid and an equilateral triangle. Okay. For C, Draw 2 shapes of your own that have no lines of symmetry. Ooh, here will be my first one. I've drawn another trapezoid, but it doesn't have symmetry. You can draw something different, okay? And we'll go like this. We'll draw a funky shape like that. That also does not have symmetry. And then, last but not least, write a definition for a line of symmetry. I'm going to go ahead and say a line that divides a shape into 2 halves that match exactly if you fold them. On top of each other. Okay, so there's mine. You may go ahead and fill out yours and then post yours into Seesaw, okay? Okay, so it would be awesome if we could play this really cool game in the classroom, but you might be able to play it at your house if you can get creative, okay? So it's called Mosaic Game. So each pair of players would need pattern blocks, but you could always pretend and just draw them. A 1 through 6 numbered die. Maybe you could find that in a game box that you have. 2 colored pencils, 2 rulers, and a game board, which are on the next page, okay? So each player rolls the die, and the player with the higher roll goes first. The player rolls the die 3 times. For each roll, he or she takes a pair of pattern blocks, or you draw them, okay? And the pattern block key is on the record sheet. So it shows which pair of pattern blocks to take for each number on the die. So, for example, if you were to roll a 1, you would get, let me erase that and try that again, sorry. If you were to roll a 1, you would get this one. If you were to roll a 2, you would get the square, or draw the square. If you were to roll a 3, you would go ahead and you would draw the trapezoid. If you were to roll a 4, you would get the hexagon. If you were to roll a 5, you would get the regular rhombus. And if you were to roll a 6, you would get the skinny rhombus, okay? And then from there, so then the players would make a design with the 6 pattern blocks. He or she gets a point for every line of symmetry in the design. Both players, the one who made the design and his or her partner, sketch the design on the record sheet, for example, just like this, okay? And then draw the line of symmetry. Players take turns until each player has gone twice. After 2 rounds, players add their total number of lines of symmetry. The player with the higher total score wins the game. There are different variations, though, of the game, so partners collaborate on a design to help each other find lines of symmetry. Players use the Mosaic Game Challenge page instead of the regular page, which you will see as well in just a moment. And then players take 1 or 3 pattern blocks with each roll instead of 2, so they end up with a total of 3 or 9 blocks instead of just 6. What happens is that it's easier or it's harder to make symmetrical shapes with more or fewer pieces. Is it easier or harder to make symmetrical shapes with an odd number of pieces rather than an even number of pieces? Interesting. And then if you take a look over here, so if you're on student book page 185, that's where I'm getting this information. Think about strategy for this game. Will you always be able to make a design with 1 line of symmetry? Not sure. Will you always be able to make a shape with more than 1 line of symmetry? And And think about what numbers would be best to roll to ensure that you have multiple lines of symmetry. So there is some strategy to this game. So if you do get a chance to play it, it's a lot of fun. Here is the regular game record sheet. Okay, notice that it does have that same thing at the top. So I know that you can't see, but if you were to roll a 1, that would be the green pattern block. Don't have orange, I don't think. If you were to roll, the trapezoid would be red. Hexagon is yellow. This is actually blue. Technically, this one would be orange, but that's okay. So it's kind of like that. Okay. So this would be your game sheet that you would use for the regular. And then this would be your game sheet for the challenge. Roll the die just as before, but this time take the number of pattern blocks indicated on the new pattern block key. So if you were to roll a 1, you would take 4 of these. If you were to roll a 2, you would take 2 of these. If you were to roll a 3, you would take 2 of these. If you were to roll a 4, you would take 1 of these. If you were to roll a 5, you would take 3 of these. And if you were to roll a 6, you would take 4 of those. So that's how that one works. Make the game a little bit more fun that way, okay? All right, and then there you have your spaces to draw as well. So there's that. Again, if you do have time to play this game or a chance to, it is a lot of fun. All right, so what you are going to do for homework tonight is for each of the shapes below, decide whether the shape has any lines of symmetry, and then I want you to draw all the lines of symmetry. So again, decide whether the shape has any lines of symmetry and draw all the lines of symmetry that you find, okay? So we have an isosceles trapezoid, an equilateral triangle, a rhombus, another rhombus, a square, and a regular hexagon. So complete that, and I want you to upload that into Seesaw. And then I also would like you to watch the Brain Pop video on transformations. And if you forgot the login, it is, whoopsies, you don't want that. PD student. The password is student. Watch the video. And take the quiz.